Welcome to AROYA Office Hours Live. She's back. Hey, everyone. My name is Mandy, and I'll be your moderator for today's discussion. A couple of reminders before we do get started. This hour is your chance to hear from the experts, get answers in real time about data you're seeing within your grow, and share cultivation tips and tricks with other growers in this exciting industry. We thank everyone in advance for not using this time for things like airing policy or industry grievances, or asking about AROYA pricing, although you are always welcome to book a demo with us. Feel free to type your questions in the chat at any time. If your question is selected, we'll have you unmute yourself and go ahead and ask away. Anyone who asks their question live for the first time today will get an AROYA hat, limited to US residents only, and 1 hat per household. Plus, today we're raffling off one of our limited edition AROYA shirts. So to enter for that, just enter your email in our chat. Seth and Jason, how's it growing?
So far, so good.
Yep, it's been a good day, Mandy. It's springtime here in the Northwest, which it's not warm or sunny yet, but it's not snowing, you know.
Oh my gosh, it sounds beautiful. It's already 100 degrees in Texas. So yeah, I'm living vicariously through you guys. So how's it been going this week? You guys ready for some of our cultivation questions that we got sent in this week?
Yeah, absolutely.
Awesome. Okay, we'll go ahead and start with some of the Instagram submissions. So Chris Mix wants to know, what is is it typical that water content decreases as the root mass increases? The highest water content I get is 40% in RW week 3.
RW?
Thinking he's referring to rock wool.
Oh, okay, cool.
So, I mean, it's kind of a two-part question here. The first part, yes, water content does go down as roots increase in mass and fill out that pore space in there. But typically you're seeing more of a reduction from like 70 to 80% down to 55 to 65. It kind of sounds like he probably had a few over drying events where he dipped below 35 to 40%. And that led to a decrease in max field capacity because you start to develop hydrophobic pockets inside of rock wool at those sorts of saturation levels, water or volumetric water content levels.
Yeah, one good practice to do is to try and get the sensors installed either before you've slit the slabs after pre-soak or just right after. And that can kind of set a really nice baseline for what your field capacity or saturation point is in that substrate specifically. In rock wool, there's probably the least variations between the different manufacturers, but there can still be slight variation depending on specifically what line of product that you're using. And the root mass, one thing to kind of keep in mind as well is roots do have mostly water content as their component of volume, and our sensors are going to read that as water content if water is in those roots. So keep that stuff in mind.
Awesome. Thank you, guys. So we're going to go on down our list. Cap Ain't Cappin' wrote in to ask, I'm hearing people say that you don't use P2, only P1. Why?
So we always usually talk about P1 and P2 events for our generative steering. A lot of times you don't need P2 events as long as you have an appropriately sized substrate. So as far as a verbal definition of P1 and P2, that's talking about phase 1, phase 2. Some people talk about phase 3 as a non-irrigation time. But I usually only like to talk about phase 1, phase 2, and then maybe dryback as another terminology for that phase 3. And phase 1 usually is the irrigations that are stacked up in order to get to field capacity, and P2 being those to maintain that field capacity. So depending on the strain, the amount of steering that we need to apply, a lot of times we can get away with 1 hour, maybe 2 hours of P1 irrigations to get to saturation or field capacity, and then we simply allow the rest of the duration to be dryback until that next day.
Yeah, and I think an important thing to remember, we talk about P1 a lot in relation to generative steering. It's a big question we get, what's going on there and why wouldn't I be applying P2s in generative steering? And something to remember is, whenever we give the plant an irrigation event, we're triggering metabolic activity. So the more irrigation we have, the more we can push that plant to grow vegetatively. So we really focus a lot on maximizing your P1 in generative by trying to go to bigger shots and minimizing the number of shots. in order to apply stress in the way we want to. It's not about going to the lowest water content possible. It's about spacing out those events.
Yeah, and I mean there's a balance with everything. When if we push a plant too far generatively, we're not going to get the best results. If we push a plant too far vegetatively, we're not going to get the best results. And so I know we always kind of talked about it like on a digital spectrum, or you're either generative or vegetative. And the reality is it's a balance within the environment and doing the best irrigation for those strain types. And I've talked about. Maybe Mac 1 is a very generative leaning strain anyways, Blue Dream as a very vegetative leaning strain anyways. And so you can really go through the spectrum on how much you want to lean on either side of the steering aspects rather than just being one way or the other.
Yeah, and the important thing there is, data logging and saving that information for later so you can look back and go, okay, here's how this plant responded. When we're pushing it with X amount of shots in a given time, or we are or aren't running P2s for a given amount of time, how's that affecting it? Because the range, really, like we're just talking about tools that growers can have in their toolbox to accomplish, a certain outcome. They're not a universal rule that's going to apply to everything. So it's more important to understand the principles of what's going on and then apply that to what you're documenting and seeing with your own plants.
And we make this disclaimer quite a bit when we make recommendations like that as far as crop steering goes. Substrate size and environmental parameters being appropriate for the size of plant that you're growing is absolute must in order to achieve the best results here. If we've gone into a substrate that's just simply way too small for the types of plants that we're growing, we're going to have a really hard time applying a generative strategy simply because that plant is going to be running out of water content. It's going to feel a generative response. We're going to have to push a vegetative response just to keep the substrate from drying out completely the next day. So yeah, keep that in mind. Try to get all of your other parameters in line before you start pushing crop steering too far.
Great. Thank you guys for that. So we do have some new questions that have just been submitted in our chat. Steezy Employee 007 wants to know, are there different settings for the lights on AROYA Nose sensors?
Different settings. I'm not sure exactly what we're looking for here.
So the lights, all they're going to do is indicate whether the device is awake, asleep, or you've just reset it. There's not really a way to change any of those settings. There's 3 flashes red for asleep or off, 3 flashes green for on or reporting.
And then if you hold the button and you need to reboot the device, hold it down for 5 or 6 seconds, and then just keep an eye on it. It should flash green, I think, while it's rebooting, and then make sure it's in the wake status if that's where you want it to be.
Great. Steezy Employee 007, please just chat us and let us know if that answered your question. They did have another question too. Is it possible to implement having the AROYA Nose sensors to detect the pH of the substrate/root zone?
No, not currently with the Taros 12 that's deployed on the AROYA Noses. There are some substrate pH devices that are available on the market for spot checking from other companies, from some pretty well-known pH sensors. One of the things is, if you're in rock wool, that device is going to auger a fairly large hole into that rock wool media. And so if you are going to do that, keep in mind that you might be compromising some of the characteristics of that substrate slightly. And I'd recommend probably leaving that pH sensor in there for as long as you can. So if you go in there and take a reading, you're not getting a difference than you would expect simply because the amount of air or water that's being caught in that cavity that's created.
Yeah, right now, honestly, it's pretty, I don't want to say totally new technology, but as far as pH sensing is concerned, a lot of sensors require fairly regular calibration. The more precise your instrument, the more you're calibrating it. If any of you have spent time in almost any kind of chemistry lab or biological lab, you're calibrating your pH sensors daily, and you're not going to be able to do that when it's inserted into the media. So that's certainly a limitation. So even if you have a great sensor, if you're looking at, readings over time, you probably want to start looking at, comparing that to actual substrate samples that you then take back to the lab and analyze and say, okay, how far is this sensor drifting? you kind of go down an expensive rabbit hole when you can really accomplish a lot with runoff sampling in regards to monitoring your pH.
It all starts with accurately measuring. Hey, we do have some extra people who have joined our chat. So if you guys have any questions, please do let us know in the chat. You can ask or you can leave it in the chat and I'll ask for you. Awesome. So I'll just go ahead and keep going down our list. We had a lot of questions this week on Instagram. I'm going to get this one wrong. F or Gino wants to know, is there any update on the open sprinkler compatibility that we had mentioned before, and what data logger would you use for home use?
2 questions in there. First one, open sprinkler. We're making good headway on it. Currently have it deployed in some of our employee facilities. I've got some going at my house. Scott, our CEO's got one running in his garden at his place. So, implementation wise, it is functioning. We're just refining some of the interface designs that we're doing and verifying complete functionality so that we have 100% reliability when we hit the market with it. And then what data logger for home use? Seth?
Well, right now, some of the offerings out there for basic data loggers, I would say, don't usually offer the convenience features that you want in a home system. So you can look at Hobo or a few others. Right now, my biggest recommendation would be to get a Solus and get a good old spreadsheet out on your phone or your computer and start mapping some of those measurements, and then just come up with a protocol and say, all right, what's realistic for me today? How much can I sample? What's my size? Can I get 3 times a day? Can I get 5? And just slowly start to try to maximize it that way. You can use Excel or Google Sheets to create your own graphs fairly simply. But do realize that at this point in time, data logging is a fairly expensive service across the board. It's definitely more in the professional sphere, and there hasn't been a lot of optimization for home use in that aspect. If you're really into programming and building stuff, go build your own little Raspberry Pi unit. There's a lot of routes to go.
That sounded like a metaphor at the end of that. Great. I wanted to open up the floor to some of the guests that have joined us. Does anyone have a question they want to ask? You guys are welcome to just go ahead and pop right in. Kevin? Yeah, go ahead.
He's trying. We still got him on mute, though.
No, you're still on mute.
Oh, there we go. I was trying to tap the mute button on my little screen. Hey, everybody.
How's it going, Kevin?
Hey, what's up, Seth? How are you, brother?
Pretty good.
So I'm curious a couple things about how long do you want to start with that generative 2 phase, after the second round of bulking, and how and then the second part of that question is how does increasing water volume the last week or something to lower the substrate EC have an effect on that generative hardening off?
Gotcha. So typically we want to cut to ripening 2 to 3 weeks before harvest, strain dependent. Some strains that are stretchier, we actually might not bulk very much at all. We might want to ripen pretty early just to make sure we get, some of that good bud formation. But cool. Dropping EC, basically what we're looking at is as the plant, we see some cues. It's starting to get really late in its life cycle, starting to get some more red pistils, starting to see those trichomes mature. The plant really doesn't need nearly as much nutrient in solution to uptake. It's just not using it. But the thing we want to avoid is dropping that osmotic pressure down to the point where we've now reversed the way it's going to work. So that plant's building up sugar content in its roots throughout its entire lifespan. And if we've kept it at a 4+ EC for the last 2 months, it's pretty well adapted to that range. And if we drop that down to 0.2, 0.1, suddenly we've reversed that osmotic pressure, and now water wants to come out of the plant almost rather than into it for a short time.
Yeah.
So what we're doing is basically causing some cellular death inside the plant. And at the end of the day, the other side of it is that plant still needs some of these nutrients to stay alive. And as we all know, a weak plant is more easily infected by mold, powdery mildew, everything we don't want to see So that's why sometimes, if you flush really hard, you might see some bud going in that's like really nice looking. You didn't find much mold, but right away, day 1, day 2 of the hang, if you didn't get it dry fast enough, it's molding out. Well, we want to have the healthiest plant possible going in. We don't want a totally dead plant.
Cool. Yeah. And then I just got like a general question for the app that we got on our phone. Like, for your developers, can we get a refresh button on our flowering room page?
Yeah, we'll put that in.
Yeah, because the dashboard is like, I gotta go to flower 1, then back to flower 4 if I want to get a refresh. So,
Right. Right.
Hook it up.
Yeah, thanks for the ammo on the feature request, dude. Customer testimonial is how we get software to listen even more.
Cool. Well, thank you for answering my question. You guys are killing it. I'll bow out.
Right. Talk to you soon, Kevin.
Later.
Thanks for that question, Kevin. Make sure you give us your email address so we can be sure that we send you a hat. And same thing for you, Steezy Employee 007. I would still like to keep the floor open. Does anyone else want to hop in and ask their question? And if not, I can just keep going down my list. Okay, no big deal. I'm sure you guys are going to come up with something. Okay, so I'm going to go on down. Dan, the grower, wants to know, I'm installing my sensors. Is it okay to place them vertically in a plastic pot?
No, you're going to always want to use your sensor alignment tool. And, you find the slot appropriate for your media. Specifically, whether you've got a 1 or 2 gallon pot, if you've got rock wool, cocoa, 2 to 3 gallon, 4 to 5 gallon pot. But you always want to install it horizontally, because if you install it vertically, either from below or above, you're actually sensing a gradient. And what we're looking for is, volumetric water content at a specific horizontal level, because gravity goes down and we've got a suspended water table that exists where cohesion overcomes gravity. So we want an even reading. And the only way we'll get that is by putting it in horizontally at a consistent level across all of our pots. Now, when you say plastic pots too, if you're using round pots, you're going to want to cut a slot in the side before you pot up the plant, and probably put some duct tape inside and outside to keep your soil from falling out, and stab through that, just so you can get all 3 of those prongs evenly seated in the media. If you've got a square-sided pot, again, you probably want to cut a slit, or you can drill 3 holes, but the slit's really the easiest to make sure those are fully seated up against the media, especially if you think about a couple millimeter thick plastic pot versus a 0.5 millimeter of fabric or soft plastic.
Awesome. Thank you, guys. And just to remind you guys, you are welcome to hop in anytime and ask a question. Just go ahead and ask away. So next up on my list, Terp Queen wants to know, how quickly can we expect to start logging our data after setting up AROYA?
As soon as you assign your devices to a room and your gateway is online, things are connected, it's going to be logging immediately to those rooms. So basically, installation steps are going to be connect your gateway to the internet and power source if needed. If you're running a PoE network switch, then you can just plug it right in with an Ethernet cable, Cat5 cable. It's going to have a red light indicating that the power's on. It's going to have a flashing orange or green light to indicate that it's accurately connected to your network, your local network. And then jump into your AROYA page, go on to the setup page, check out, make sure that gateway's online, start hooking up your repeaters, your climate stations, and then lastly, start getting your substrate sensors assigned. And so turning those substrate sensors on gets them activated. Press the button 1, 2, or 3 times so that it flashes the screen at least once. So just tap it, tap it, tap it, and it'll flash green at least once or twice, and it'll be on. And best thing you can do is just make sure that your repeaters have good signal strength, your climate station has good signal strength on those substrate sensors, and the whole system will start piping data as soon as you're assigned to a room.
Yeah, and I want to build on that and just say, if you're worried about, organizing it, it logs immediately. So even if you wait a week to build out your first harvest group, let's say you get it installed and you get super busy, that harvest group can still be backdated and find that historical data. Everything that's coming into the system is always being recorded. It's just up to you to organize it. which is something we'd love to help you out with too.
Yeah,
we can also help with that.
On the other side of that, we get a question on how long is data going to be available. So we store your data in the database for you to actively get a hold of for as long as you're subscribed to the AROYA system. So I've got clients, I think about 3.5 years of data at this point since we began deploying sensor systems.
Yeah, and you also have the option, like what I often recommend people do just as a good business practice, is you can actually export that data in CSV format. So get an Excel or Docs sheet or a Google Sheet. But what you'll want to do is manipulate on the graph which values you actually want to download and probably say, okay, I'm downloading this data once weekly or once monthly, or the way I prefer to do it is download a data set for a specific run and store that locally. Downside, though, is then you get to go in and remake your own graphs, but it's still a nice option.
Yeah, and I think the last option there would be utilize our open API to grab sensor data that you want on a consistent basis. I mean, you're welcome to pipe that to your own database or use it in any other processing ways that you'd like to.
Great. Thank you, guys. We did get a lot of questions in the chat. I'll just go ahead and start at the top. Steezy Employee 007 wants to know, is it better to increase the duration of feedings if water content drops below target threshold, or add water feedings past the recommended time for generative growth during flowering?
Ooh, I wish we had a board to draw on behind us. Typically, the best, so the situation you're describing sounds a lot like ripening and having a, media volume that's slightly too small for your plant size or way too small. Typically, what we'll try to do is just stretch out the distance between the end of P1 and then roughly 2 hours before lights out, maybe a little earlier, put on what we call a maintenance shot to correct that dryback overnight. So basically, we're going to try to put, let's say if we're, drying down to 34%, we don't want to go below 40. We're going to put on 6% at the end of the day to try to correct that amount and not over dry. And the thing about it is by doing that, instead of adding, several P2s, just that one, we're not giving it a very strong generative cue at all. We're just helping to maintain our, media properties and not over dry and lose that field capacity.
Awesome. Steezy Employee 007, please let us know if that answered your question. Okay, I'm going to go on down the list. Brian Rogers, do you want to go ahead and take yourself off mute and ask, or I can ask for you? I can go ahead and ask for you. Brian wants to know, as it relates to dryback, what percentage of dryback per hour is appropriate? And is that a percentage of the total volume of the substrate or a percentage of the then current water content?
Yeah, it's going to be the percentage of total volume of substrate. So anytime that we're looking at our readings, the reason that water content a lot of times for rock will be at, say, 65 or 70% for field capacity, because that is the amount of water in that volume of product, right? So if we had 1 gallon of media and we're reading 70% content, that means we have 0.7 gallons of water totally within that. Usually the other amount of that space is either the media itself and or air pores, some oxygen content. As far as the ideal dryback percentage per hour, that's going to be based on the transpiration rate of those plants. So obviously we're usually shooting for as high as transpiration as possible. Other than maybe if we're increasing our CO2, in which water use efficiency would go up, and we don't necessarily need quite as much transpiration to have the same photosynthetic amount of photosynthetic rate. So as far as an exact number for you, it's really going to be dependent on how happy your plants are. Usually the higher the better.
Yeah, so especially if we're talking about bulking, we want to get as many irrigation events on in P2 as possible. So the faster you're achieving a dryback, the better. But that dryback's also kind of a culmination and a summation of a lot of different things going on in your environment. So if you're running a higher temp environment and you can't drop your temperature lower because you will have humidity problems, that's a limitation you're going to work in and say, okay, I'm operating at these higher temperatures later on. That's what we got. So there is, no ideal amount, but if you can get like 3 to 5% per hour in bulking, you're really rocking it. I'll put it that way. That's really going to help you get a lot of those on, but it all comes at the expense of making sure you have a media size that's appropriate. So by the time you get to ripening, you don't have a plant that's so big that you can't run it generatively.
Awesome. Brian, you'll have to let us know if that answered your question. Great information, guys. Joel had a question too. Joel, do you want to take yourself off mute and ask? I can totally ask for you too. All right, I'm going to hop on in. I have a question. Joel has a question about vegging under LEDs. Oh, he can't get his mic on. No big deal. Thank you. Joel has a question about... Oh, there we go.
Hey, thanks for having me, guys. I really appreciate it and appreciate all you guys are doing. I have a question. I am vegging currently under LEDs, and we're unable to get our percentage up over about 65 without experiencing some sort of what appears to be like a light burn. And then also on the flip side, then when we're putting them into flower, we're flowering under HIDs. And we also have to turn those quite a bit down, it seems like, to get them from like what it seems to be would be burning. Is there anything you could offer to help out with this?
Sure. Let's talk just kind of about the basic principles of light in this case. And I really like to veg under LEDs simply because they typically have a little bit more in the blue spectrum, and that helps early plant development. For details there, getting some PPFD readings and making sure that you're keeping your lights at a sufficient distance from those plants. Those are going to be that's the two best things that you can do to track where you really need to be at lights. Cannabis plants are very light hungry type of plant, and so I think maybe there's a little bit of history where people thought they need to baby them through the transition, really take it easy. And one of the best principles that I like to apply is making sure that you have the same DLI coming out of veg as you do going into flower. And so when we've got 18 hours of light, we'll have a specific DLI. And when we go into flower, since we're actually decreasing the light by 6 hours, we're going to have to increase by about 33%. And that way the plant can still get the same amount of energy and keep at the photosynthetic rate that it has been, even though it is going through a transition time. It needs more light intensity so that it can achieve the same DLI. Specifically as far as light burn, make sure it is light burn. So go in there with PPFD, take some sensor readings. If you've got a quantum sensor from us, that's a really nice way to kind of keep track of that. It'll calculate DLI for you as well. Start jotting that down. Maybe play with your intensities a little bit. Make sure that there is enough space between your lights and your plants. Historically, a lot of times, light burn can be confused just simply with the amount of heat that's coming off of them, and or some of the other issues, maybe a little nutrient deficiency. A lot of times, people call it bleaching. I don't know if that's specifically what you're experiencing, but usually that just has to do with the plant getting so much light that some of those chlorophyll actually starts to be deactivated in those plant cells up towards the top.
Yeah, one thing I like to think about in all this is when we throw a seed out in the yard, that's getting hit with full sunlight right off the bat. So when we take a cut and we put it into 150 ppfd in cloning, all that new tissue that's developing, the new leaves that come out of that clone, unless we're bringing that PPFD up strategically fairly quickly, we're not going to increase chlorophyll production. So the plant actually, it needs to do something on its own side to adapt to that higher PPFD. So a big problem I see is people coming out of, clone and not tuning that ramp up. So they'll go, all right, we're going from 150 to 250 to 350. Well, we've really got to try to attack that aggressively, because if you've got a 2-week veg, and the reality is we need to be getting up to 550, 600 in order to match our DLI at 950, 1,000 going into flower, or even higher if we've got CO2 and we can push that 1,200 plus. We've just really got to get those plants hardened off quickly. And a big part of that is giving them, everything they need. One thing I really commonly see is people hand feeding with like a 2.0 EC in veg. The problem with that is it's really hard to be accurate and actually build EC in your root zone when you're hand feeding like that, especially if you've got like a 4-inch pot or a 1-gallon cocoa pot. So if your plant doesn't have the nitrogen and other nutrients it needs to build that chlorophyll and really harden off to the light, that you're going to see, burning that's actually related to a deficiency because the plant just can't metabolize quick enough to keep up with all the energy you're giving it. So in the end, get a PPFD meter if you don't already have one, and just start tracking that as close as you can, and then set your goals. Like I said, if you've got a 2-week veg, you've got to get to 650. That's a goal. And in 2 weeks, that can be hard. If you're looking at 3 to 4 weeks, it's a lot less of a challenge.
Yeah, for sure. Awesome. Well, that answers it. I definitely think that's some starting point for me to try to troubleshoot this and something to play with to try to correct the issue I'm seeing. So yeah, greatly appreciate it, and thank you guys very much.
Absolutely. Thanks for asking.
Thanks, Joel, for that question. And Michael actually chatted, we've run 1,000 to 1,800 ppfd, and our biggest adjustment as the lights increase is following up with adjusted watering patterns. A bit more runoff keeps us from even having to change our incoming EC, assuming the nutrient balance is on point. Thanks for that, Michael.
You nailed it there, buddy.
Yeah, we love this. Thanks for sharing, everybody. Seriously. Michael, does anyone have any new questions to ask? I know it's a full house today, and we're just like moving right along. But if anyone has any questions, you guys are welcome to jump right in and ask Seth and Jason. Otherwise, I'm just going to keep going through the Instagram questions that we have.
I'm going to add on to Michael's comment here as well. If you are increasing your light intensity, you probably want to keep an eye on increasing your CO2 as well, unless you're already above those requirements. There's a lot of great resources online that'll show the capacity for plants to digest CO2 dependent on light source intake. So make sure those are matched up. If you're already above CO2, then no need to worry about it, but you also could probably reduce CO2 to stay more efficient at your facility if those aren't matched up.
Awesome. Thanks for that, Jason. Michael actually chatted back too. 1-to-1 ratio in my experience, 1 ppm to 1 ppfd.
Yep, that's right on point. That's a very easy way to keep up on it. And also, if you're 1-to-1, that's going to avoid you attempting to spend a lot of money putting way too much CO2 in there. I think that's one of the most difficult parts of that, because we're either talking about CO2 burners or buying tanks of CO2. Both have their pros and cons. The tank CO2 is not the cheapest thing ever. And, well, do we really want to have a burner in our indoor grow room? That's not exactly, that's just one more fire hazard. So it's a thing to balance for sure.
My general rule of thumb is I like to run plus 200. So plus 200 ppm over your ppfd. So if we're at 800 ppfd, then I like to be at 1,000 ppm CO2. That's my personal preference, but just depends how lean we're trying to get, and just check in on the science. Photosynthesis is CO2 plus water catalyzed by light. So it's pretty much a simple breakdown of what those charts show.
Yeah, and to add to that, it's something to pay attention to, especially the research on that, because we're getting more and more advanced lights coming out with better and better spectrums, and a lot of the research is showing that, the more modern advanced lights are actually a lot more efficient in terms of CO2 consumption. So things you can do with some of the latest LEDs are, in terms of CO2, things you couldn't do, 5-10 years ago with a single-ended HPS bulb.
Yeah, and that's a great point. So that gets into some of my most favorite conversations, and that's talking about light spectrums and how they affect plant growth. So obviously, if we're taking a ppfd reading, that's a summation of all the photons over photosynthetic flux density. So we're looking at, all right, here's all the spectrum, here's the photons that we're getting across that spectrum. Plants can have specific absorption rates at chlorophyll A and chlorophyll B, and so it is going to depend on your lights as far as what that ratio needs to be as for ppfd to CO2 intake.
Great. Thank you, guys. We do have another question that came in through the chat. David has a question. Do you want to unmute yourself? Oh, awesome. Perfect. I'll go ahead and ask.
Yeah. Hi, guys. Sorry, my name is David. I can't figure out how to change you to show up on the screen properly. So please forgive me, technically challenged here. Yeah, I'd like to see, can you make some comments on circulating your nutrient as opposed to dumping it? I know a lot of guys, it's industry standard to dump it, but it seems like a big waste to dump. And just to tell you why I'm asking that question is we're sort of the Johnny come lately with a new growing medium called Growzor. And we are running trials and tests, and our runoff is really, really clean. And we're trying to do some testing in order to bring validity to using your nutrients more than, running it through more than just once.
Yeah, so I think probably one of the reasons that it's not super common right now is it does take some a little bit more advanced equipment, and the thing that you absolutely have to do is get a nutrient composition of that recirculated nutrients. So if your plant if it was eating up all of the nutrients at the exact same rate, then we would just have a decreased concentration of a perfectly balanced nutrients in our runoff. The reality of it is, I don't think there's any nutrient lines out there that are always going to match the exact requirements, those nutrient requirements that all of your plants have, strain by strain. And so when you do recirculate, the balance, the composition of the different elements in that nutrients is something you're really going to have to keep an eye on and make sure that you're supplementing any of the nutrient levels or any of the element levels that are low in that nutrient composition coming back into your system.
Yeah, in an ideal world, at least in my opinion, one thing you can use AROYA for is to really, start to run a little bit lower EC and maximize, your performance you're getting out of your feed by modulating your runoff. So really, if we can go with minimal runoff, give the plant everything it needs, because the other reality about recirculating, and I do find a lot of merit to it, but if you spend some time talking to like guys who are running, big recirculating ebb and flow or deep water culture setups, they still have to dump a certain volume every week, every month, just because they've got to refresh that. You can't keep amending something when your concentration of ions goes too far one way or the other. For example, most of our plant essential elements or nutrients are cations. Some are anions, but when we look at pH, we're looking at the concentration of positive ions in there. So if all we ever do is take out mostly cations, eventually that downward trend in pH is going to catch up to us, and only correcting that pH with pH up isn't going to do it. We've got to actually get rid of a lot of those ions the same way you would need to flush them out of your media. That's why we still need to run, that 5, 10, 15% runoff regularly. So I think it's cool. One thing I do see coming in the future as far as remediating that runoff is bioremediation. There's already technology out there. We can grow algae with it and press that algae for biodiesel. Remediation ponds that grow other things. We can use it to grow vegetables afterward. There's a lot of things we can do with it, but recirculating at a certain point, I think, starts to become a really expensive technical challenge. And that's just my opinion. I know there's a lot of people putting a lot more time and effort into this than I am.
Great. Did that answer your question, or?
Yeah, I would love to have pick your brains a little bit more on maybe offline here, because we are doing some bizarre, weird things.
Absolutely. Do you have my email, David?
I do not yet. I came in late, and I'm sad I did that.
Well, I think Mandy can provide it for you, and let's talk off air.
Cool, thanks.
Be very interested.
Yep. I'll make sure I get that to you, David. Thank you so much for that question. We have a couple of people who have joined us. Jeremiah, if you have any questions, be sure to enter them in the chat. Great. Steezy, employee 007, got a question right before you did, so I'm going to go ahead and hit that one. What improvements and changes are there between the current AROYA sensor nose and the previous model that was more rectangular?
Yeah, so what we did was we just changed up the mold a little bit to increase our assembly efficiencies. As far as the internals, electronics are all the same. And so most all of the differences is just a little bit different form factor. You'll notice that it's lighter, so it's not epoxy filled anymore, and keeps the shipping costs down a little bit, and it just makes it a lot faster for us to manufacture.
Yep, just case design. The sensor itself is still identical.
Awesome. Thanks, guys. Okay, we're moving on down. Jeremiah, do you want to go ahead and ask your question directly to Jason and Seth? Oh, you're on mute. Happened to me earlier.
Sorry, can you hear me?
Yep, we're good.
Hey, what's up, guys? I've noticed the last few runs I've been keeping my core EC much higher during ripening, and I'm noticing it's helping the color come out a lot more toward the end. Do you think this is something I should keep pursuing?
So when you say core EC, I'm just assuming that means root zone EC?
Yeah, the lowest point after the P1.
Gotcha.
Yeah, so obviously what we recommend for ripening is to have pretty significant drybacks, and so that is going to push your average EC for the day pretty high, even if you do reduce your feeds. That's why we like to call it ripening, because we're looking at the substrate EC on average. And having a high EC there is definitely going to signal the plant to push as much finishing growth to the buds as possible. And I think that's what you're seeing with the color.
Yeah, and part of what that does really is as that EC goes up higher and higher, it makes it a lot harder for the plant to uptake pretty much all nutrients and even a little bit of water. So there's definitely a point of diminishing returns on the high EC as well. And a lot of times you'll see that in, really burnt leaves. Obviously burnt. Sometimes you'll see some stamens come out, then little hermaphrodited plants. So it's not bad. We recommend not a super high. That being said, I see a lot of success strain dependent with people pushing that, 15 plus on the high end. And certain strains don't seem to mind it at all.
Thank you, guys.
Absolutely. Hopefully be talking to you soon, Jeremiah.
Yeah, Jeremiah, great question. Reminder to anyone who asked a question today, please do drop your email in the chat. We are raffling off one of our limited edition AROYA t-shirts, and anyone who asked a question for the first time today gets an awesome AROYA hat. I believe Seth is wearing the one that we're giving out today. So yeah, we're still getting some more questions, really exciting stuff. Cool, let's see what's next. Brian wants to know, Brian, do you want to take yourself off mute and ask this one?
Yeah, thank you. We wanted to know if there are good reasons to have larger drybacks or if staying at a more constant WC is just the same.
Can we get a little bit more specifics on what you're referring to, time frames or what your goals are?
Really at any stage of growth and for any of the goals. And if there's different answers to that question at different stages of growth, then, if it's too much to cover all of them, then I would say, for the first maybe 21 days of flower, if we have, let's say several waterings or irrigation events per day, is it better to increase our events and decrease the duration of each event to maintain a more constant WC at that stage of growth? Or is there a benefit to the drying nearly back to acceptably, dry and then all the way up to acceptably wet or even to field capacity?
Gotcha. So kind of running the range there. Well, when you're talking about like a large dryback, that actual dryback number is a pretty big reflection of your light inputs and VPD in the room. So how much is the plant requiring in terms of water input to photosynthesize as much as it can, given us how much light it has? And then how much water potential do we have in the air that's actually pulling that water up through the plant? So basically, the dryback number is less important than the time we're actually giving it between irrigation events, because each of those irrigation events is telling the plant to metabolize. In an extreme situation, if we did one watering event in the daytime and dried it back for 23 hours and 45 minutes, let's say, that's pretty extreme generative growth because those roots don't photosynthesize, all right? They're getting carbohydrates from the plant above it, and then they have to metabolize those using oxygen. similar to, any other cellular respiration. So there's really not a benefit in, like, the difference you're talking about is basically the difference between vegetative and generative steering. If we keep that water content up with small drybacks, that's giving the plant more and more opportunities to have the oxygen to metabolize, uptake that water, and build plant structure. So if you're worried about dryback number, focus more on, let's say if you're in Rockwool, not going below 40%, than actually pushing the big number. It's more about what can you do with the minimum number of shots in a day for generative, and then vegetative, exactly opposite. How can we optimize the biggest number of small shots if we want to push it as vegetative as possible?
Great, thank you.
You're welcome.
Awesome, you guys. Thanks for dropping your email addresses in this chat. So Michael does have a question. Michael, do you want to take yourself off mute and go ahead and ask them directly? Or I can ask for you for sure. So Michael wants to know, can we get a brief rundown of the new irrigation part of the system? So we did touch on this a little bit earlier, but do you guys want to go a little bit more in depth?
Yeah, we sure do. I'm really excited about it. Everyone I talked to is really excited about it. So a good portion of our existing clients are using open sprinkler systems. It's been around in the industry for quite a while now. I think almost a decade ago was when he started building those open sprinklers in the early days. And fairly inexpensive system. It's caught on in the cannabis industry quite a bit because of how flexible it is. A lot of the other irrigation controllers out there don't let you run as many irrigations as you'd like, or be able to build the programs and manipulate them as easy as possible. It's a web-based interface that you can easily access when you're away from your facility as well. So that's kind of one of the reasons that we've wanted to allow you to push irrigations to the open sprinkler right from AROYA. So obviously, this is one of our first steps in doing control type of work, and what you're going to be able to do in the AROYA system is very similar to what you do in the open sprinkler interface. So this is going to just help you stay out of a whole bunch of different interfaces on the day-to-day, to give you a little bit more secure connection to start pushing information to your open sprinkler when you are using the internet away from the facility. And we really, really like harvest groups. As you guys know, if you've been watching the show, I'm preaching about all the time how that's a great way to organize your teams, organize your data, and really refine your crop steering techniques to start improving how well you cultivate. And so when we talk about the different steering techniques, we've got generative in our recipes, we've got vegetative in our recipes, maybe we have a specific rooting in phase, and you'll be able to describe what irrigation patterns you want for each of those phases, save it into your AROYA recipe, and AROYA is going to update that schedule when you get to that day. So if you're doing a great job staying on schedule with your harvest group, you don't need to even remember to go in to change the program in your open sprinkler. AROYA is going to simply ask, do you want to change to your generative phase today? And you're going to say yes, and it'll go in and push the new pre-saved irrigation right into that open sprinkler. So there, we're also going to have a dashboard that just overviews the irrigations that you have set up for all your rooms and your harvest groups, and should be pretty good for anybody that's been using the open sprinkler.
Yeah, and if you haven't, I don't know how long some people have been using sprinkler controllers, but no more dials, no more 3-4 digit screens that you have to go through menu after menu to program each individual event as a program. The future's looking bright for irrigation. There's been a lot of products over the years that a lot of them almost get there, and then the user interface is oftentimes pretty difficult. So I'm really stoked. We've even been able to take like Open Sprinkler themselves. They have a wonderful dashboard. Honestly, a lot more than most cannabis growers need, and most greenhouse or indoor growers in general. And we're able to take all the good things we like out of that, and then maybe some of the ones that don't influence our indoor growers. Like, we don't need to watch out for how much it's supposed to rain that day and issues like that. But the fact that it can't all be supported also is really cool to me, just as a plant nerd.
Oh, it's super exciting stuff, you guys. So we do have one last question that came in through Instagram today. So, and we are nearing the end of our show. So if you guys have, yes, exactly. If you have any questions, please do drop them in the chat. So I'll go ahead and get to Steezy's question real quick. Are there any plans to make a device like the SKALA, but something that constantly monitors plants in dry rooms and gives feedback on AROYA about the moisture content within the plants?
So not specifically, no. There's other ways that we can kind of track that stuff. Obviously, the best way is to use something like the Aqua Lab right now and take a daily sample and then map that out. So, if we know the humidity and the temperatures in the rooms, we can actually start to make a very good prediction of what that water activity in the product is going to be, as long as we've mapped out that strain type before. And we've done this in the meat processing industries, smoked meats, jerkies, sausages, that type of stuff. And it works very well. If you grab enough samples, you can realistically model the drying patterns of those, and then you almost don't even need a device to do it, as long as you consistently take samples and track any of the new product configurations that are going into that process.
Yeah, I mean, and you can even think of it just like you're growing at home. I use one nose T12 combo on every plant in my house that I grow. Do you need that? No. You can blow that up. You can scale that up quite a bit and still use that information. So here, using something like the Aqua Lab, you can start to build models for strains. What kind of density do we get with this strain? What can we expect? It took us how long to dry? How much? Really, there is a lot of data collection modeling in the beginning, but over time, just like Jason said, you can start to actually rely on those moisture measurements within the room, humidity, temperature, and see, okay, given this line I've achieved in the past, how close am I to achieving that this time? And if I can lay that line over each other time and time again with my environmental control, all I have to do is, day 7, 8, 9, 10 through 14, go pull a sample and say, is it ready like I think it should be? And if not, well, make some notes and correct your model a little bit.
Great. It's all about refining, right? We do have one last question that came in through Instagram, and I'll just get to it real quickly. Dank Grow 33 wrote in to ask, do AROYA sensors help with conservation, like water or nutrients, those types of things?
Yeah, absolutely. Seth did a great job talking about this earlier in this show here, is by knowing the ideal water contents and managing the right amount of runoff, you can make the most of your nutrients that you're inputting. So you're not running off nutrients, you're not running off water, you're saving as much as you can, both financially and waste-wise.
Yeah, I mean, I'll put it this way, 8-9 years ago, when I first learned about growing in cocoa from some forums that I'm sure we were all on back in the day, some of the instructions were, as far as drain to waste, if you're in a small pot, mix up a bucket of nutrient solution, just dunk that pot in until it stops bubbling. Do that a few times with your different pots, then go throw that nutrient solution out in the garden or down the drain. So we've really come a long ways in making these whole operations more efficient. And like I said, even the deep water culture, you always have to throw that away somewhere. You can't just keep it circulating that same solution forever. Eventually you end up with a pretty negative solution that's, well, positive, but negative for our purposes, a solution that's pretty impossible to amend. So AROYA can really help you become more efficient, not just in your water usage, but also, timing tasks. A lot of our clients are finding that being precise with crop steering and water management leads to, 3, 4, 5 day reduction in ripening time for certain strains that they thought, we had to go 69, 75 days with. We can get this one out in 65, 63. Just because we've been able to be so consistent with everything up to that point that we didn't stall the plant out on the way. Because when we're talking, 63 days, let's say, is a pretty good standard I like to go by, down to 56 sometimes if I've got the right strains. Each day is well over 1% of that plant's life. Everything we do in that time period is impactful. And if you stall things out 2 days here, 2 days there, pretty soon you think it takes longer than it does. And you haven't been able to prove otherwise, because if you haven't data logged everything, you can't necessarily identify the differences that certain, even horticultural practices will have, let alone irrigation.
Perfect. We love hearing that. AROYA helps with conservation, with everything, with pest management, with water. We love to hear that. Well, unless there's any other questions that we have, yes, Steezy, please do leave your email for the hat. Yes. Unless we have any other questions, we're going to go ahead and end today's show. Anyone who did ask a question, please leave your email in the chat. Thank you guys for asking all of your awesome crop steering and cultivation questions and joining us for this week's AROYA Office Hours Live. Do you have questions about AROYA or how it can be used to improve your cultivation production process, or any other topic you'd like covered in the future on this show? Please post it in our chat. You can shoot us an email at support.aroya@metergroup.com, or you can send us an Instagram DM. We'd love to hear from you. We do record every session, and we'll be emailing everyone in attendance a link to the video from today's discussion. It'll also live on the AROYA YouTube channel. Like and subscribe while you're there. And if you find these conversations helpful, please feel free to share them with your network and spread the word. We'll see you guys next time. Thanks so much for coming out. Thanks, guys.
See you next week.
See you next week, everyone. Thanks, Mandy.
Yeah.